In the summer of 1877, famine swept across India, China, Brazil, and southern Africa. Across multiple continents, streets and villages were filled with the bodies of those who starved. In India alone, roughly 20 million people died. They succumbed to starvation following a catastrophic failure of the harvest, rather than war or disease. The root cause of this global famine was completely invisible to the people suffering through it. It started thousands of miles away, in a small patch of the Pacific Ocean off the coast of Peru, where the water suddenly became unusually warm. This isolated temperature shift erased winter entirely in places like Minnesota and halted the rains that global crops desperately needed. Now, major forecasting centers like the ECMWF and NOAA are tracking a rare ocean pattern forming. Their latest models point to a 140-year anomaly. By 2026, we are looking at the return of a super El Niño. In 1877, this natural ocean fluctuation killed tens of millions of people. Today, that exact same force is hitting a modern planet that is already severely overheating. To understand the physical threat, we have to look at how the Pacific Ocean operates. The Pacific is the largest and deepest ocean on Earth, and usually strong air currents called trade winds push the warm surface water west, moving it constantly toward Australia and Asia. Because that warm water is constantly moving away, it creates a vacuum. This pulls deep, cold, nutrient-rich water up to the surface near South America. This cycle keeps global temperatures and rainfall patterns balanced. This heat map shows exactly what happens during an El Niño. The trade winds weaken. The warm water stops moving west and instead pools right up against the western coast of the Americas. Trillions of liters of ocean water get unusually hot, and as that heat releases into the atmosphere, it shifts where clouds form and rain falls. A drop in open ocean winds translates directly to extreme Australian droughts, failed monsoons in India, and broken global agricultural cycles. Our baseline global temperature has already risen by roughly 1.4 degrees Celsius since the pre-industrial era, entirely driven by human emissions. An extreme El Niño event typically adds another 1.5 degrees to that global average. Stacked together, we are looking at a 2.9-degree temperature spike, a shift never before recorded in human history. It is the equivalent of sitting inside a room already sweltering at 40 degrees, and someone walking in and plugging in a space heater. This double-layered heat brings immediate consequences. First, the monsoon rains fail right when crops need them most. With over half of India's agriculture depending entirely on rainwater, crop yields drop sharply. This leads directly to the second layer, a 9% spike in food prices, making basic groceries drastically more expensive for everyone. The third layer is a relentless streak of extreme daytime heat waves. And the fourth is the environment we live in. We have replaced natural trees and open green spaces with dense, sprawling concrete. This creates the urban heat island effect, where the concrete absorbs the scorching sun all day and slowly radiates that heat back out long after the sun goes down. Heat waves kill mostly in the dark. When the nighttime temperature refuses to drop below 30 degrees, human bodies cannot physically cool down or recover from the daytime exposure. The risk of sudden heat stroke multiplies. You might expect national disaster funds to activate during these extremes, but in India, cold waves are classified as official disasters, while heat waves are not. The government avoids giving heat waves this official status because doing so would legally require them to pay a 4 lakh rupee compensation out of the national fund for every confirmed heat-related death. Instead of preparing our cities, authorities are actively removing our best defense. Tens of thousands of ancient, old-growth trees are being cut down across our major urban centers right now to make way for mining plants, for new concrete highways, and rapid urban developments. Officials often claim they plant 10 saplings for every tree they cut, but newly planted saplings take decades to grow, and up to 90% of them die in isolated patches. Meanwhile, studies show that preserving existing mature trees actively drops the temperature at the pedestrian level by a full 12 degrees. The infrastructure that should protect citizens is actively making the environment hotter. Getting through the extreme heat of 2026 is going to require individuals to prepare themselves and step up for their own communities. you have to treat the peak hours of the day like a lockdown. Stay out of the sun strictly between 12 p.m. and 4 p.m. Keep oral rehydration solution, or ORS packets, on hand at all times. They cost pennies, but they restore essential salts and are your absolute first line of medical defense against severe dehydration. Look out for the millions of informal workers who do not have the luxury of staying indoors. Delivery riders, construction workers, and street vendors see their daily earnings plummet during extreme heat because they have to spend their limited wages on ice and medicine. Offer them cold water, and if you have shaded space, offer them a place to rest. Long-term, you can detach yourself from the systems causing this heat. Over 70% of India's electricity still comes from burning coal. By installing solar panels on rooftops or balconies, you not only secure your own power supply, but you stop feeding the emissions that keep driving our baseline temperatures higher. Children being born today will never know what a normal summer feels like. The 35-degree summers we grew up with are gone. For this next generation, 45 degrees will be the default expectation. The ocean is already warming, and the super El Niño is on its way. But by planning ahead, investing in our own energy independence, and looking out for the most vulnerable people in our neighborhoods, we can survive the brutal summers ahead.